Hey guys, I'm going to be doing the AP Calculus AB 2016 FRQ question 4 on differential equations. So let's just jump right into it. So it says, consider the differential equation dy over dx equals y squared over x minus 1. And this is the grid they give us, x-axis, y-axis, and there's 6 points. Okay, so part A reads, on the axes provided, sketch a slope field for the given differential equation at the 6 points indicated. So we're going to sketch the graph, okay, and there's 1, 2, 3, y, and 1, 2, 3, x, and the 6 points were 0, 0, 0, 1, 0, 2, 2, 0, 2, 1, 2, 2. And the differential equation was dy over dx equals y squared over x minus 1. Okay, so what you want to do is you just plug into this right there using the points that you indicated. So for example, we'll go with this 0, 0 point. So it'll be 0 squared over 0 minus 1, which equals 0, right? So the slope right here is 0. Okay. Oops. Okay. And then for the next one, we'll use 0, 1. So it'll be 1 squared, because that's the y, 1 over 0 minus 1, which equals 1 over negative 1, which equals negative 1. So the slope right here is going to be negative 1. Okay. And now for the next point, 0, 2. So we'll have 2 squared over 0 minus 1, which equals 4 over negative 1, which equals negative 4. So right here, the slope is going to be negative 4. So as best as you can, make sure that the slope is steeper than the negative 1, but you don't have to be exact, just there you go. So those are the first three, and it's the same on the other side. So we'll go 0 or 2, 0. So it'll be 0 squared over 2 minus 1. So it's going to be 0. And then we'll go 2, 1. It's going to be 1 squared over 2 minus 1, which is going to be 1 over 1. So the slope for this one is going to be 1. And then we'll do 2, 2. So it's going to be 2 squared over 2 minus 1, which equals 4 over 1, which equals 4. So the slope for this one is going to be 4. Okay. So make sure for this one that you have your 2 zero slopes and then your 4 other non-zero slopes. And that's basically that question. So now we'll go into part B, which reads, let y equal f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3 Write an equation for the tangent line to the graph of y equals f of x at x equals 2. Use your equation to approximate f of 2.1. So we'll break this up into two parts. First we'll find the equation, and then we'll find the approximation. So they also give us an initial condition to consider and tell us that y is equal to f of x, which we should know. So remember, when you're differentiating, you're finding the slope of the tangent line. So that means that dy over dx will be the slope of the tangent line, right? And we said that this equation is equal to y squared over x minus 1, okay? And in the question, they told us that y is equal to f of x. So that means we can just substitute f of x into y, all right? So that means f of x squared over x minus 1, and then you substitute with your initial condition. We'll write initial condition equaling 2, 3. And now you just substitute right there. So f of 2, because that's what they gave you, over 2 minus 1, and they said that f of 2 equals 3, so now you can put 3 squared over 2 minus 1, which equals 9 over 1, which equals 9. So that's your slope of the tangent line. Now they want you to write the equation for the slope of the tangent line. Now the slope for the tangent line is this equation. Y minus y1 equals m times x minus x1. And they gave you y1 and x1, and you just found the slope. So you would write y minus 3 equals 9 times x minus 2. And you just bring over the 3, and you have your equation. Let's see, y equals 9 times x minus 2 plus 3. And that's your equation. So that's just part 1 of this question. Next, they want you to approximate using that equation that you just found. So we'll write that equation again. Y equals 9 times x minus 2 plus 3. And now they gave you an x, an initial condition. So they said that they want you to find f of 2.1. This 2.1 is x. So you just substitute this in. We'll use brown. Y equals 9 times 2.1, 2.1 minus 2 plus 3, so it equals 9 times 0.1 plus 3, which equals 0.9 plus 3, which equals approximately 3.9. 0.9. So this is your approximation. Okay, that was part B. Now you can go on to part C, which reads, find the particular solution y equals f of x to the given differential equation with the initial condition f of 2 equals 3. Okay. So, remember that this is the differential equation they gave you. dy over dx equals y squared over x minus 1. And you want to get the variables onto either side, so you separate them. So this would be dx multiply, because then these cancel. And then this side would be the inverse of y squared. So that would be that, and that cancels. And now you multiply both to either side. So you end up with dy over y squared equaling dx over x minus 1. And because these were differentiated, you want to take the integral to get the normal base without anything like that. So you want to get rid of the dy and dx essentially. So to do that, you would integrate both sides, okay? And we'll do one side at a time. So we'll do the dy first. So you have dy over y squared. This is just a normal power rule, so I would bring the y squared to the top, making this -2, right? And so a power rule, so you add 1, and then -2 plus 1 equals -1. So this becomes negative y, -1, which is equal to 1 over y. Okay, -1 over y, sorry. So we'll mark that over here, -1 over y, and that's equal to the dy over y squared. And now we'll work with the dx over x minus 1, which is essentially 1 over x minus 1, that's an x, minus 1 times dx. And you should notice that this looks like a natural log, so that means that the integrated version of that would be ln of x minus 1. And because you're taking the integral of the x, you have to add a constant plus c, and that is this. So now you have the -1 over y equaling the natural log of x minus 1 plus constant c. Okay. Now, we'll rewrite this. So -1 over y equaling ln x minus 1 plus c. Now you just plug and chug with the initial condition, which said that f of 2, 2 being x, equals 3, which will be y. So you just do this, -1 over 3 equaling ln x, oops, sorry, we said that x is going to be 2 minus 1 plus c. And now you're solving for c, right? And so any good calculus student would realize that this equals 1 right there. 2 minus 1 equals 1, plus c, that's plus, and ln of 1 equals 0. So you cancel that, which leaves -1/3 equaling c. So now you have value for c. Now you can solve for y. Okay, so we said that c is equal to -1/3. So you can add that up here. Like that. Okay. And now solve for y. And now solve for y. Or make it equal, make an equation that can be used to find y. So you would take the inverse of this 1 over y, which would be y, and so what you do to one side, you'll do the other, and you have a negative on the left side, so you're going to make all the values the opposite on the other side. You're going to multiply by a negative. So what this will end up equaling to is y equals 1 over 1/3, because the negative times the negative will be a positive, right? So so y equals 1 over 1/3 minus ln of x minus 1. And that is your y. You found the particular solution, y equals f of x, to the given differential equation with the initial condition. You solved for y. And that's basically it. So I hope you enjoy. If you have any questions, feel free to leave a comment, and see you guys next time.